Okay, I'm starting out in my home directory and I'm going to make a projects directory. Actually, a project directory in this case. And I need to clone the web page with the tool in it. Okay, this path is in your lecture notes, or you can Google for Python Crash Course GitHub and find it that way. It's also up here at the top of the thing. Okay, that's what you're looking for roughly. If I go over here on the green button and click, what I will do is I will click this little thing right here. You may want to do HTTPS instead, but I have SSH set up on my system. But in either case, you click the little thing to copy and paste that, get clone and the path, and once you do that, it will do some stuff, and it will give you a copy of all the material from the book, including the completed game. And now you want to go into the PCC directory, and we are looking for chapter 14. This is the completed code from chapter 14 for the game, which means I should be able to run it with just Python, but I'd really like to have it up here in Visual Studio Code so we can start working through some of it. So I'll do code dot. And before I do that, this is in a different directory than we were before. And we'll bring up Visual Studio Code in this directory. And the first thing you'll notice is that Alien Invasion right there is the main program. We would really like to run it once and see what it does. That's the first step. That's always the first step. Now, I can't actually run it inside Visual Studio Code because when I use my screen recorder and this game at the same time, they're both trying to get a hold of the screen, and guess what? They don't run together. But I will run it at the command line. You should be able to run it in Visual Studio Code. When I'm not screen recording, I can run it in Visual Studio Code. So Python Alien Invasion, and it takes a second to compile it, but we should be able to hit play. And yes, you see aliens, and maybe I'll blow one up. Yes, finally blew up an alien. Okay. So you'll notice that there is a score up there that increments as I move things. I'm hitting the space bar to shoot. If I move over with the arrow keys. Okay, this is not the most advanced game, but I think it's going to show you everything you need to know about doing a game. And here are all the reasons why. Let me just let this thing run for a second. But we have a means by which to score. It produces an image, this image of my beautiful green aliens, because you know all aliens are in fact green, and there's our little ship down here shooting at them. We have a means by which to control things, and the results of the control are changing what happens in the game. So the game actually takes characters, like spaces, left arrows, right arrows, and does things to control the space aliens, or control the shooting process. Now, the combination of those things is enough to train our system. And here's where I'd like to talk about what's going on out there in the world and why this is a good example to work with. Because, this is an ancient Space Invaders game. 30 years ago, this is what people played for computer games, and they thought it was fun. I'm a little bit fascinated because I used to pay money to pay this, but basically, it's not that entertaining a game. But the code for it is relatively simple. Let me close the game here. And let's talk about the stuff that is happening that makes this really interesting. First of all, you can get your head wrapped around the code. It'll take a little while. And we're going to dig into the code and look through it a little bit and see how we're going to have to change it. But it's not that complicated a piece of code. So we can understand it. Now, with a self-driving car, you've got LiDAR, you've got cameras, you want to merge different pictures. The process of merging pictures and collecting data is complex. Then you want to grade the data. You want to do a whole slew of hard image processing things. This is synthetic data. We don't have to do any fancy image processing. It's kind of just given to us. The colors are consistent. All sorts of things we don't have to mess around with. But at the same time, the two are not really much different. We have an environment that has things in it, and we have a means by which to do control of our device that results in changing the environment. And from a very naive perspective, what's a car? It's got all these sensory inputs, the environment. It has to navigate the car, it has to send out signals to control its environment and change the future. Now, why do I think that machine learning and automated cars is such a big deal? Well, in 49 of 50 states in the United States, the most common job for somebody to get is a truck driver. And I know something about being a truck driver. I was a long-haul truck driver for a while. Yes, I went up the road, down the road, up the road, down the road, up the road, down the road. In this case, it was from Southern California to Seattle, back and forth. Just back and forth. That same piece of the world, back and forth and back and forth and back and forth. Delivering fresh vegetables as fast as we could deliver it. And yes, it did make some money, but it wasn't that entertaining. And living in the back of a truck, as in there was two of us running this one truck with a contract, so we basically ran it 24 hours a day, except when we were eating or trying to remember to take a shower or some things like that. But it was all day and all night long. Now, legally, you're limited to 11 hours of driving a day, which we fudged the books and we made 11 and a half each a day. I will admit to that, and that's not what you're supposed to do, but lots of truck drivers do it. But 11 and a half hours a day meant that we drove 23 hours a day. We never turned off the truck. I mean, literally, we ran that thing 24 hours a day, basically, for weeks at a time, going back and forth. And that's not much of a life. It's an ugly life. It's a dangerous job. It's very, very monotonous, mixed with moments of pure, unadulterated terror as you think you're going to die. So, this is an interesting job. But remember that means that most trucks, they have one driver, are only running 11 hours a day. And from a capital perspective, that means that half of the trucking fleet in the United States is sitting idle, half of every day. If you replace the driver with a computer, you could run it 24 hours a day, non-stop. You could double the efficiency of trucking. Now, if you read the annual report of Nestle for the past 3 quarters consecutively, they have pointed out that they are not performing their business at the level they would like to because they simply cannot hire enough truck drivers to deliver all the products they would like to. Yes, they are short of truck drivers, and that has become common in our economy. Even after this virus, we are still short of truck drivers. So not only are they in short supply, but they're only using the trucks half the time. So the combination of these things is going to drive self-driving trucks into reality very quickly. There are already self-driving trucks on a big chunk of Interstate 10 in Southern California to New Mexico, doing deliveries on a daily basis right now on the roads. And in the past couple weeks, we've seen that Waymo has actually announced that yes, it is going to start doing self-driving and I have that article right here. And let's talk about 6.1 million miles of self-driving in Phoenix. They are now doing driverless taxis in Phoenix. Waymo is the Google self-driving division. And you'll notice it mentions that they've had 47 collisions. Normally, insurance companies figure that they're going to have a collision involving collection of money about once in every 90,000 miles. So 47 collisions in 6.1 million miles is way, way better than human beings are doing driving. Now, out of those 47, Google has figured out that they are only responsible for one. All the others are human drivers hitting their cars. So 47 is a lot more than is what you would actually count. The one case that they are responsible, their car backed into another vehicle at 1 mile an hour. So although there was damage, it certainly was not life-threatening. So the combination of this means that they have nearly a perfect driving record. Now, one of the huge impacts that's going to come out of self-driving cars is a third of all medical care in the United States is due to driving accidents. We're talking surgeries, people dying, rehabilitation, physical therapy, hospitalizations. 1/3 of one of the biggest industries in the United States is driven by car accidents. And if you can put self-driving cars with this kind of a record in there, those guys are going to disappear. That's just going to be gone. Okay? That will be the biggest advancement in health since basically public sanitation took place. It is that big a deal. 250,000 people a year die from car accidents. And I don't know, it's something like 5.5 million people are severely injured a year. So they're actually releasing their data, and they're talking about that. But yes, they are now doing self-driving without drivers in Phoenix. And it's only a matter of time before this expands. Tesla, okay? And this is with some criticism that they're not ready. The criticism is because they don't have nearly as good a driving record as does Waymo. But their driving record is substantially better than human beings. And they're claiming full self-driving for the entire United States. So, although, they are not as good, it's a much broader area. It's not just one city. And how much better? If you want safety, turn on the self-driving in a Tesla and let it do the driving. It is 2/3 to twice as good as the human beings driving the car. So are they having accidents? Yes. Could they do better? Yes. Do they know that? Yes. And what is the biggest problem that Tesla has in not improving their process? They don't have the training data. Now, Teslas communicate over the cell network, and what is getting rolled out right now, if any of you have seen an advertisement at all, you know that what is happening in the cellular network is 5G. Okay, 5G is 10 to 50 times the throughput of our current 4G cellular network. And who is the biggest contractor buying 5G right now? Well, you might think it's the phone companies like Apple and people building Androids. No, it's Tesla. For their cars? Yeah, because every one of their cars produces terabytes of data a day that's being thrown away because they can't transfer it back to use it as training data. But as soon as they get 5G in their cars, every one of these is going to be the biggest data collection devices. And unlike human beings that have gotten about as good as they're going to get, okay, in driving cars, computers can get substantially better. They can get from where they are as Teslas to where Waymo is because they've been collecting the data for quite a while. So this is a huge, huge change. 5.1 million people are truck drivers in the United States. And also, 92% of the time cars sit idle. They aren't actually running. So we're probably going to move to a world where instead of buying a car, you buy transportation on demand. Basically the Uber model of self-driving cars. And this is going to be a big deal. Now, how does this relate to us and our little game? Well, our little game, we're going to take our little game with its space aliens, and we are going to use the same software that Google developed for their self-driving cars, TensorFlow, and we are going to take that software, and we're going to show you, I'm going to show you and work with you on how to make this game play itself. So we're going to add some code to it that captures the score. We're going to add some code to it that captures images of the screen. And then we're going to train TensorFlow to sit there and say, oh, well, this is one of the things that I should send out as data, as a behavior. And it will know how to click the play button and send one of those randomly. And that's going to get it a better score. And it will do this until the game ends, and it will build a training set. And after a while, it will figure out that, yes, it is supposed to send a whole bunch of these all at once. And it will get better. And it will keep getting better. And pretty soon, it's going to learn to move the little spaceship over and send another one. And it is going to optimize the behavior of each of these, playing thousands of games to learn how to play the game. So this is what we're going to do with TensorFlow. Now, to do that, we got to get into the code and see what to change in the code. Because right now it's expecting human input, not a computer input. And it's not saving the images. And we've got to take the stuff for TensorFlow, now that we've got TensorFlow installed, and start combining it with the game and merging it and modifying it. So that's where we're going with this. And I am just excited beyond conception about this. This is just, I mean, who doesn't want to kill nasty green space aliens in bunches? And what could not be good about this? All right. With that, I'm going to leave you, but we're going to delve into the code in the next piece and start looking at it.